In this section, we're going to discuss how we solve quadratic equations by extracting square roots. And then we're going to get to another method called completing the square. Alright, so solving quadratic equations by extracting square roots and completing the square. Before we get to actually solving by extracting square roots, we want to review how we solve quadratic equations by factoring, what we've been normally doing. Alright, what we normally do, let's look at this example here, x squared minus 7x equals negative 10. What we would normally do is get all of our terms on one side, so we add 10 to both sides. And then we try to see if we can factor, right? This is three terms. There's a 1 in front of our x squared, so we're going to factor into two binomials. Put an x here and x here. Two numbers that multiply to give me a positive 10, but add up to a negative 7. Those two numbers will be negative 5 and negative 2. All right, now that we have these factored, we have two things that multiply, or they have a product that's equal to 0. So what we're going to do is set each of them equal to 0 using our zero factor property. If I add 5 to both sides to this equation, I get x equals 5. And if I add 2 to both sides to this equation, I get x equals 2. So my solution set will be 5 and 2. Okay? That's what we normally do when we solve a quadratic equation by factoring. Let's go to part B. We have x squared minus 18 equals 0. If you look at this example, everything is already on one side set equal to 0. So what we have to do next is try to factor. Well, if I look, there is no GCF, and I have two terms. Now, normally with factoring, when we have two terms, there's only three ways to factor. A difference of squares, a difference of cubes, and a sum of cubes. All right? Since this is an x squared, it looks like we can do a difference of squares. All right? However, 18 is not a perfect square. All right? So instead of doing any more thinking about that, we're going to come up with a new method to help us solve this type of equation. All right, I have two terms, and it's not one of those three things that I can factor. Three methods to factor. So what I'm going to do is I'm going to isolate my x squared term. Right? Remember, isolate means get on one side completely by itself. Right? So what I'd have to do here is add 18 to both sides. Right? So I'm going to add 18 to both sides. When I add 18 to both sides, I'm going to get an x squared equals 18. All right? Now what I have is just x squared by itself. All right? What I'm going to do to get that x from being squared is to take the square root of both sides. All right? So this is kind of the opposite of what we did to solve radical equations. We normally had a square root of x, but we raised both sides to the second power. Well, this time we have an x squared, so we're going to do the opposite. We're going to take the square root of both sides. Now, back when we first started this chapter, we said, or actually chapter 9, we said that, well, the square root of x squared is actually the absolute value of x. So I get absolute value of x equals the square root of 18. I'm just going to leave square root of 18 as it is right now. All right? So what I really have right in here is an absolute value equation. All right? However, the x is still an absolute value. It's not completely isolated. So when we talked about absolute value equations, we said, well, you take whatever's in your absolute value, set it equal to the positive, and set it equal to the negative. All right, way back at the beginning of the semester. And so now that I have this, I have x equals a positive square root of 18, x equals a negative square root of 18. Instead of always going through this process with absolute values, what we're just going to do is we're just going to remember to put on a plus or minus when we take the square root. All right, so this is the mathematics, what we're actually doing here. This is the mathematics here. All right, all of this is the mathematics. But what we're going to do, since we know that, hey, this is going to be an absolute value equation, and all I have to do is set it equal to the positive or negative, when I take the square root in this step right here, what I'm immediately going to do, I'm going to skip all this green stuff. I'm going to immediately go here. All I'm going to do is remember to put on the plus or minus. All right? And so we have x completely isolated. We want to make sure our answer is in simplest form. All right. 18 has a perfect square as a factor, right? 9 is that one, that perfect square. That's a factor of 18. I can write it as 9 times 2. And so we get that x equals plus or minus 3 times the square root of 2. All right, so we actually have two solutions here. Remember, that's two solutions. I have a positive 3 square root of 2 and a negative 3 square root of 2. This is how it may look in the solution set. All right, this method that we just went through is called extracting square roots. Here are the steps that we just took. All right, first thing is to isolate the square term. Then we're going to take the square root of both sides. We got to remember to add on the plus or minus. That's the plus or minus there. And then we're going to solve for our variable. All right, isolate, take the square root, remember plus or minus, and then solve. Those are the steps that we're going to take to help us solve these types of equations. All right, quadratic equations. All right, let's look at an example. All right, I have x minus 5 squared plus 10 equals 34. All right, first step is to isolate the squared term, right? This is my squared term here. The thing that's preventing me from having it isolated is this 10 right here. So I'm going to subtract 10 from both sides. When I subtract 10, I'm going to get an x minus 5 squared equals 24. Now my squared term is isolated. Notice, it is still isolated. Even though it has an x minus 5 in it, it's still isolated. It's completely by itself. Now that I have this squared, that kind of inverse operation would be to take the square root of both sides. All right. When I take the square root of both sides, we're not going to worry about absolute value stuff. This is going to be an x minus 5. All right. But to take care of that absolute value, I'm going to put on the plus or minus, and we get the square root of 24. All right. And so now this is pretty much solved, right? X still has that minus 5 with it. What I'm going to do right now is I'm going to go ahead and simplify the square root of 24. All right. Square root of 24, the largest perfect square that goes evenly into 24 is 4. We can write it as 4 times 6. And so that means that x minus 5 is the same exact thing as plus or minus 2 times the square root of 6. Now, of course, x isn't completely isolated. I'm going to add 5 to both sides. All right. The 5's here are going to cancel, so I am left with x. Do not try to combine like terms, because these are not like terms. This one has a square root of 6. That 2 has a square root of 6 with it. The 5 doesn't. And so the way I normally write my answer is I put the number that doesn't have a radical first, and then my plus or minus part second. And so if I want to write my solution, it'd be 5 plus 2 times the square root of 6, or 5 minus 2 times the square root of 6. And there's our solution. We're going to look at one more example of this. 2 times the quantity 2x minus 3 squared plus 17 equals negative 1. Again, first step is to isolate your radical. All right, so not radical, your square term. The things that have me preventing me from having this isolated is this 2 that's multiplied on the outside and this 17 that's added on the outside. All right, so I'm going to kind of treat this 2x minus 3 all squared kind of like a variable. What we would do if this whole thing was a variable is we would add 17 to both sides. Okay, so we'll subtract 17 from both sides since that's an addition in the problem. All right, so I have a negative 17. I'm applying that to both sides. And so I get negative 1 minus 17, which is negative 18. Now, what I do not want you to try to do is to distribute here, all right? I don't want you to distribute because this is not a distributive property. The distributive property says that if I have A times B plus C, then that's going to equal AB plus AC, all right? Notice the exponent on this distributive property is a 1. Since that is a 2, this is not going to work for you. Now, there are problems where it will work, but it will not work for every problem, so I always say never do it if it's not going to work for every problem. All right, so I have this 2 sitting out here. Since that's a multiplication between the 2 and that set of parentheses with that squared term, I'm going to divide both sides by 2. And this allows me to get rid of that 2 that's multiplied on the outside. And therefore, we have an isolated square term. Once it's isolated, we can take the square root of both sides. We get 2x minus 3 equals plus or minus, and this one is simple enough to to take the square root of. We have a negative, so I know I'm going to have an I in my answer. Square root of 9 is 3. So this is going to be 3i. Now that I have this, I can add 3 to both sides. So I have 2x equals, and in the same fashion that I did before, I'm going to put the plus or minus part second. So I have 3 plus or minus 3i. And then I can divide both sides by 2. And I get x equals that thing right there. 3 plus or minus 3i all over 2. And one thing that you can do, you can, since it's all over 2, you can divide this by 2, and you can divide that by 2. And that's the way you're probably going to want to enter your answer in ByMathLabs Plus if you were using that. That's 3 halves plus 3 halves I and 3 halves minus 3 halves I. All right, so with this extracting square root stuff, when we have 2 terms, notice in all of these we had 2 terms, even though some of the terms were binomials, like this 2x minus 3. All right, but this gives us another way that we can solve a quadratic equation when we have 2 terms. Now we're going to get to another method, and it's called completing the square. All right, completing the square is a procedure that's used to solve a quadratic equation that can't be solved by factoring or extracting square roots. All right, can't be solved by factoring or extracting square roots. All right, so of course, not all quadratics can be solved by factoring. All right, and extracting square roots only works for polynomials of 2 terms. All right, or they're given, or they look like they have 2 terms in them. Completing the square makes use of what we call a perfect square trinomial. All right, a perfect square trinomial is a trinomial that can be factored into a binomial squared. All right, for instance, x squared. Let's use another color here. X squared plus 2x plus 1. All right, I'm going to say that this is a perfect square trinomial. All right, and if I wanted to factor that, it would factor into x plus 1 times x plus 1. All right, and of course, when we have 2 things that are the same and we're multiplying them, we can just say that that's squared. All right, so this is the same thing as x plus 1 squared. This is what we call a perfect square trinomial. Every single solitary perfect square trinomial factors into a squared binomial. All right, and so we're going to make use of this, or we're going to turn any polynomial with 3 terms into a polynomial that at least has part of it being a perfect square trinomial. All right, these are the steps to completing the square. All right, we know that the standard or general form for quadratic is ax squared plus bx plus c equals 0. All right, when we have a problem and we want to complete the square, the first thing that we're going to do is we're going to get our variable terms on one side and our constant terms on the other side. So basically, I only want to see ax squared plus bx part. C needs to move to the other side. All right, then we're going to divide or multiply to make sure that a equals 1. We don't want a number other than 1 in front of our x squared term. It makes completing the square a lot more difficult. All right, so that's our second step. This third step is the step that we actually use to complete the square. We're going to find b over 2. So take half of your middle term b, right? B is always multiplied by x. Take half of that and square it. Simplify it, see what it equals, and then add it to both sides of the equation. Okay? For instance, if I look at this example here, I have my b in this example is 2. So if I take half of 2 and square it, that's 1 squared or 1. It'll always be the number here that you're going to need in order to factor into a binomial squared. All right, so this part right here is the most important part of completing the square. Without it, we can't do it. All right, then we're going to factor into a perfect square trinomial, and then we're going to solve by extracting square roots. We're going to look at one example of this. It is going to take some practice, but it's always going to be the same pretty much. All right, let's look at this example. 2x squared minus 3x plus 92 equals 0. I want to solve this by completing the square. Well, the first step said to get my variable terms on one side. These are my variable terms here, and my constant term on the other side. That means I need to subtract 92 from both sides. That being said, we'll get 2x squared minus 32x equals negative 92. Okay. Now I need to make sure that my leading coefficient, or my a, is 1. Well, right now it is not 1. It's a 2. In order for me to get 1, I need to divide both sides of my equation by 2. That means everything in your equation gets divided by 2. And so I have x squared minus 16x, and that's going to equal negative 46. Okay. Next step is the completing the square step, right? My b term is negative 16, right? I want to figure out what b over 2 all squared is, all right? Well, my b is negative 16. I'm going to square it. Negative 16 divided by 2 is negative 8. I want to square that. And negative 8 squared is 64. So what I'm going to do is I'm going to go and I'm going to add 64 to both sides of my equation, right? And you add it so that it stays balanced. So I get the equation x squared minus 16x plus 64 equals, well, negative 46 plus 64 is a positive 18. All right? So I've done my completing the square step. Now I'm going to factor. All right? Two numbers that multiply to give me a positive 64 add up to a negative 16 is negative 8 and negative 8. And just as a shortcut, the number is always sitting here. All right? If it's a negative number, make sure you put the negative in for b here, and then it'll always be this number sitting here. All right? That's a way to check yourself. Well, if I look at this, this is the same thing as x minus 8 squared equals 18. And now I have a problem that looks like extracting square roots. So I'm going to go and I'm going to extract square roots, take the square root of both sides. I'll get x minus 8 equals, we got to remember the plus or minus. 18 can be written as 9 times 2, right, if I want to simplify it. And so I end up with x minus 8 equals plus or minus 3 times the square root of 2. And if we add 8 to both sides, not in that fashion, but add 8 to both sides, we're going to get that x equals 8 plus or minus 3 times the square root of 2. All right, and as a solution set, you can write 8 plus 3 square roots of 2, 8 minus 3 square roots of 2. All right, so that's completing the square in a nutshell. All right, the last thing we're going to talk about in this section here. All right, so we have 3 methods now to solve a quadratic equation: factoring, extracting square roots, and completing the square. And to be honest, completing the square lends itself back to extracting square roots. All right, but in all those examples, I gave you the quadratic equation, and I asked you to find the solution. What we want to do now is, hey, well, if I give you the solution to a quadratic equation, can you tell me what the solution, what the actual quadratic equation was? All right, so I'm going to give you solutions. Tell me what quadratic equation it came from. All right. First of all, what we're going to do is we're going to create factors by subtracting solutions from x. All right, so these are the steps. I'm going to start working on this first example here. This is a solution set. All right, 3 and 2, right? That's just saying that, hey, if my variable is x, x equals 2. Or for a solution, we get x equals 3. All right. Well, I can always subtract something from both sides of the equation, right? So I'm going to get x minus 2 equals 0 And here, if I subtract the 3, which is my solution, from x, I get x minus 3 equals 0. All right? So that's what this first step is sort of saying. Create factors by subtracting solutions from x. All right? The reason why I did that is because, hey, well, now I have x minus 2 equals 0 and x minus 3 equals 0. Well, if I multiply those two things together, x minus 2 and x minus 3, that's still going to be 0 times 0, or 0. And so now I have two things that multiply together to give me 0, kind of the backwards of what we do with factoring. All right? So this looks like it's in factored form. I'm going to unfactor it. All right? I get x squared minus 3x. And I have to distribute here. Minus 2x plus 6 equals 0. And I can combine my middle two terms, that negative 3x and negative 2x. I get x squared minus 5x plus 6 equals 0. All right, so it's working backwards. What we normally do is we start with our equation. All right, if we're using factoring, we'll go all the way up to this step right here and factor. Then we set everything equal to 0, and then we solve for x. We're just doing everything backwards here. Let's look at negative 9i and positive 9i. All right, and this is basically what these steps right here are saying. All right, negative 9i and a positive 9i. Well, we all know we're going to start with x equals negative 9i, or x equals a positive 9i. Of course, I'm going to add 9i to both sides here. And I'm going to subtract 9i in this equation here. So we get x plus 9i equals 0. And on this right equation, x minus 9i equals 0. All right? Well, we have two things that multiply together to give us 0. So let's set them both equal to 0. X. We have two things that are equal to 0. Let's multiply them, and we'll see that they still equal 0. All right? And of course, we're going to unfold this or distribute using our FOIL method. We're going to get an x squared minus a 9xi plus a 9xi. I don't care which order you write that in. And here we got to remember that's going to be a minus 81i squared equals 0. Now remember, I squared is the same thing as negative 1. These two things cancel here, so we're left with x squared. That's a minus 81 times I squared. I squared is negative 1. That's going to be plus 81 equals 0. Okay? Now, when we factor, when we started factoring, we found out that you can only factor when you have two terms if you have a difference of squares, difference of cubes, or a sum of cubes. This is exactly why we don't factor a sum of cubes, because to factor it, you're going to have to use imaginary numbers. And back in the day when we first started solving quadratic equations by factoring, we had no information about imaginary numbers. But this would be an example of a quadratic equation that has those solutions, and this one was for that last example. This concludes our lesson on solving quadratic equations by extracting square roots and by completing the square.